Classical physics seemed perfect. It explained everything, from falling apples to orbiting planets. But in the early 1900s, scientists noticed strange behavior at the atomic level, things classical physics couldn't explain. First, there was a problem with heat and light. When objects get hot, they glow like a red-hot iron. Classical physics predicted that at high temperatures, objects should give off infinite energy in ultraviolet light. That didn't happen. This became known as the ultraviolet catastrophe. Something was clearly wrong. Next came the photoelectric effect. When light hits a metal surface, it can knock electrons out of the metal. Classical physics said brighter light should knock out more electrons, no matter the color. But experiments showed that only certain colors or frequencies worked, no matter how bright the light was. Einstein explained this by saying light comes in packets, or particles, called photons. Then there were electrons. Classical physics imagined them orbiting the nucleus like planets around the sun, but that model didn't match reality. Electrons didn't spiral into the nucleus or give off radiation like they should. Instead, they seemed to jump between energy levels. No orbiting, just sudden moves. These strange discoveries couldn't be explained using classical ideas. Energy wasn't smooth. It came in steps. Light wasn't just a wave. It was also a particle. And particles didn't follow exact paths. They behaved like waves. To explain all this, scientists had to create a new theory of nature, quantum physics. In the next video, we'll see how quantum physics began and how it turned science upside down.